Hello there, welcome to this video all about logical operators used in Python. Now logical operators are very important, especially for your computer, because technically your computer is just a very intelligent adding machine. So it uses these Boolean operators to imply logic onto your computer. So let's have a look at how we use them in our programming. So I've got a little Visual Studio program opened up, I've got a Python application going, I've called it logical operators, saved it in the right place, and I'm just going to create this. And here we are with our project. So if I just put the title in here, logical operators. Now we're talking Boolean operators, really. Okay, so it's all about logic. And there are three distinct or main logical operators. We've got the NOT operator, we've got the AND operator, and we've got the OR operator. Okay, so we're going to fly straight into this and keep this nice and short. So the NOT operator, if you can just remember that it flips the logic. Okay, it flips the logic. If I said to you, let's output something to our console, and I said not true. Okay, so consider true. Let's put this up here. Okay, consider true as a 1 and consider false as a 0. And I'm sure you've heard about binary before and what that means. So 1 in binary is true and 0 in binary is false. So if I said not true and true is 1, not just flips the logic. So if you flip 1, it becomes a 0. If you flip a 0, it becomes a 1. Nice and simple. So this technically should return false or 0, shouldn't it? Okay. And let's have a look if that actually does happen when I run my console application. Voila. Okay, so it says false. No problem whatsoever there. That's fairly straightforward. What if I did the opposite then? What if I did not false? So if I notted a 0, that should become true. And its value should be 1. So let me just run this again. We've got true, yeah. So it takes false and it flips it. So if you put not in front of anything, it will try to flip it, okay? Invert the logic, that's what it tries to do. Okay. If I said to you, given some numbers then, what if I said not 3 greater than 2? Okay, the first thing I would say do here is look at the 3 is greater than 2. So is 3 greater than 2? Okay, is that true or false? Well, 3 is greater than 2, so that's true, isn't it? Yeah, so 3 is greater than 2, that's true. And then I just need to not that, which makes me flip it. Okay, so the actual answer is going to be false. It seems a bit strange, doesn't it? So evaluate the terms first, and then flip it if you see a not in front of it. So let's just see if this does return false. I'm not lying to you. Yes, it does. It returns false. And if I said, okay, print not 3 less than 2, what do you think that's going to be then? So evaluate the condition first. Is 3 less than 2? Nope. It's false. But we flip it, so it becomes true. Do the same format as above, and that becomes true. Okay, so 3 is not greater than 2, so that's false. And then we flip it, so it becomes true. Okay, and that's the not logical operator there. For the next one, and, okay, and states that both conditions need to be true. And I'll just put to pass there. Now what I mean by to pass is I mean to get true overall. Both conditions on either side need to be true. And I'll show you what I mean now. So if I say print false and false. So basically what does that mean? We know that false is 0 and we AND with 0. So both conditions are false. So we don't pass this here. So if we've got false and false, it's going to return false. If I had something like false, oh, I can't even spell false anymore, false and true, capital, true, what does that mean again? So we've got 0 and 1. Okay, again, both conditions need to be true. I've got false there, so that means it's going to return 0 or false again. So that's still not passed yet. If I said true this time, what about true and false? Well, that's just the same as above really, but the other way around. So we have true at 1 and false at 0. That's going to result in 0 because both conditions still are not 1 or true. Okay, so the only one that should pass is if I get true and true, because we know that true equals 1, so it's 1 and 1 equals 1. So we should have 3 falses followed by 1 pass in the AND logical operator. So let's see if that happens. Here we go. So we've got false, 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 and true. There you go. Yep, so our logic is correct there. And the last one, actually, I'll show you another example then with some numbers, just so that you know that we don't always have to use true and false. We can do something like this. What does this mean? So if I said to you, is 3 greater than 2? Okay, 3 is greater than 2, so that's true. And is 4 greater than 2? And 4 greater than 2. Yes, that's true as well. So we've got true and true. So that is the same as this one here. So we've got true, which means 1. True, that means 1. True and true is true overall. Let me just run this. So we've got true. Yeah, that's right. And you could always, if you wanted to, you could always make one of these fail. You could say, is 2 greater than 3? And is 4 greater than 2? Again, determine exactly what's going on here. Is 2 greater than 3? No, it's not. And is 4 greater than 2? Yes, it is. But because we've got a false in there, that means 0. It will return 0. Quick way to work these out is if you ever have a false or a 0 in any of your statements when using AND, it will always fail. Because look what happens. If we have a 0 in here, we get a 0. If we have a 0 in here, we get a 0. If we have a 0 in here, we get a 0. But if there's no zeros present, then it will always be 1. Okay? That's the AND logical operator. The last one is OR. So whereas the AND operator says both conditions need to be true, OR means only one condition needs to be true to pass. So let's do the same thing that we did before. Let's print false or false. We'll see if you can determine what these are. So you should already be thinking about what these are at the moment. So do the logic in your head. Print. And I'll do the other way around. I'll do true or false and print true or true. Okay, let's determine what's going on here then. So false or false, so 0 or 0 is going to get you 0 overall. Then we've got false, which is 0 or 1. And because we've got a 1 there, only one condition needs to be true for it to pass, so we pass that overall. Same thing, we've got a 1 or a 0, so because we've got a 1 in that statement, we pass. And here we've got 1 or 1, which is going to be 1 because we've got a 1 on both sides, so that's still going to pass. And again, if we do this with numbers, if you wanted to, so is 3 greater than 2, or is 4 greater than 2? So what conditions have we got there? Is 3 greater than 2? Yes, it is. So that's a 1 or a true on that side. Or 4 is 4. Actually, I'll take the numbers away. I'll put true instead so we don't confuse you. 4 is 4 greater than 2. That's true as well. So overall, that's going to be true. Okay, we do the same thing on the other side. We can flip these around. We can say true is true greater than 3, or is 4 greater than 2. What are the conditions here then? Is 2 greater than 3? No, it's not. And is 4 greater than 2? Yes, it is. But because we've got an or, that says that as long as one of these is true, the whole condition passes. So there we go, true it is. Let's just double check then that we've got this correct. So we've got, last one, it was true. Then this one was true on line 31. Then on line 29, that was true. On line 28, that was true. On line 27, that was true. And on line 26, that was false. Yep, so all these outputs are exactly what we said. So good work, everybody. Okay, and that is that. That's everything we need to know. Just the not, and, or. So for a quick recap then, just look in not, basically flip the logic, and both conditions need to be true in order for the result to be true, and or only one condition needs to be true on either side in order for the whole condition to be true.